Hello, Chemistry 11. And today what I would like to do is expand what you learned last day in regards to classifying different chemical reactions and taking the knowledge that you learned from last day and are you able to predict products of chemical reactions? Now, you folks might have done this before in grade 10, so hopefully this is a little bit of a review. Now, by knowing the reactants and the type of reactions possible, one can predict the products of the given reaction. Now, I'm focusing specifically on Chemistry 11, all right, and what we want to focus on this year. But just to be aware that there's many different categories of chemical reactions, and what I'm giving you is a very narrow focus. So for a synthesis reaction, the general starting material would be two elements. Okay. Again, that is for Chemistry 11. Now, in your textbook reading back in chapter 5, some of you might say, well, Mr. Chan, it says here, calcium oxide plus water could form calcium hydroxide. That's not two elements. But why would that be considered a synthesis? And again, the reason being is because you have two substances forming into one. That was the previous day's definition. In this case, you have two compounds going into one compound. And this is why it can be classified as a synthesis reaction. But for us this year, what I want to do is just say it's two elements. For decomposition, you start off with one compound. Okay. Single replacement is one element. And one compound. Double replacement is two compounds. In solution. And combustion is a hydrocarbon and oxygen. So what you can do is when you take a look at the starting reactants, the starting chemicals, that will give you an idea of what the products would be. Now, again, in Chemistry 11, we're giving you a very narrow focus, okay, but at least we're giving you a starting point. Now, when predicting products, one needs to remember the charges and combining capacities. So let's say for synthesis reactions. For synthesis reactions, let's say we had aluminum plus oxygen. Now, we have two elements, and most of you are saying, oh, yeah, two elements form one compound. And some people make this mistake. They go AlO2. But this is wrong. Why? Is because you need to remember aluminum, when it joins, has a charge of +3, while oxygen, when it joins, has a charge of -2, going back to chemical naming rules. And so what happens in this case is you get a formula of Al2O3. Now, this is good. What's even better is if you can balance the equation. So this will be 2, 3, 2. Oh, that's not 2. This is 4. Okay. Now, the same thing goes for all different types of reactions, but especially the double replacement reactions. Now, let me give you an example here. So let's say if we had, let's say calcium chloride and sodium carbonate. in double replacement reactions, remember they say you switch partners, but this is what some people do. They go, oh, okay, CaCO3 and Na2Cl2. Now, again, this would be wrong. Because again, you have to think back to chemical naming. So in this case, if you look at chemical naming, we break this apart. Calcium would be calcium plus 2. Chlorine would be Cl minus 1. Sodium would be Na plus 1. And CO3 would be CO3 minus 2. All right. So again, what happens is you have the switching of partners. So calcium, chlorine, and sodium go together. And what you have here is you have calcium and carbonate going together. And so what you get is, in this particular case, as a product, you would get CaCO3, oopsie, and NaCl. This would be correct. Okay, and if we wanted to balance it to make it even better, we would put 2 in front of it. Now, again, when you are predicting products, what you want to do is you always want to check the activity series. Remember, is the element in a single replacement reaction able to displace the element in the compound? Remembering this table here, okay, are you able to use this table? And for solubility table for double replacement reactions. And hopefully you remember last day's lesson where we talked about making sure you write down the phases of the products in a double replacement reaction. Okay. Now, the last thing I wanted to talk about was energies of reactions. Now, when we talk about chemical reactions, going back to the beginning of this course, remember when we talked about changes in matter, either physical or chemical, energy is involved in the breaking or formation of bonds. Okay, there's energy involved. Now, there's 2 types of bonds that we talk about. We have intramolecular bonds, which is bonds that between atoms in a molecule. And we have intermolecular bonds. So intermolecular bonds are bonds between molecules. Okay. Now, if you were thinking about what do I mean by this? Let's say we have water. So we have water, water, water. And here we have oxygen, water, water. This one between the hydrogen and oxygen of this water molecule, this would be intramolecular. And if I have the second water molecule here, this bond here would be inter. Okay. Some of you may have been taking biology 11 or biology 12 and hear about surface tension of water, and that's because of water's intermolecular bonds. Now, regardless if it is intra or inter, there is energy involved in the bonds. And when we talk about energy changes, it's represented by the symbol delta H, okay? And has the units of kilojoules per mole. Now, when talking about energy changes, there are 2 perspectives that one takes. One of them is delta H focuses on what is happening to the bond energy within the atoms, called the system, and what we feel or sense, which is called the surroundings. So when we talk about energy, it all depends on perspective. Are we looking at it from the perspective of the system or the perspective of the surroundings? Now, the example would be my classroom. If you sit in my classroom, what you will notice is the windows are on your left-hand side. But for me, the windows are found on my right-hand side. And the reason for the difference is because of perspective. We're both talking about the windows. The windows haven't changed. But for you folks, it's on the left-hand side. For me, it's on the right-hand side. And that's because it's a matter of perspective. Now, when we talk about chemical reactions for endothermic reactions, what happens is the reaction gets colder because more energy is absorbed than released. Okay? So how do we represent endothermic reactions? Well, notice in this case, energy is in the reactants. Also notice that delta H is a positive value. So what happens is because it absorbs energy, the products have more energy than the reactants. That's why delta H goes up. If you have an exothermic reaction, reaction gets hotter because more energy is released than absorbed. Okay, now, how do you recognize exothermic reactions? Notice the energy term is in the products, and delta H is a negative value because of the fact that you're losing more energy. So if you take a look here, notice the products are lower energy. Compared to the reactants, and that's for an exothermic reaction, while for an endothermic reaction, the products have higher energy. So in this case, higher energy. Now, you might say, well, Mr. Chan, I'm still struggling. Well, the idea of system and surroundings, you could think of it like this. So let's say if I had a bank here. So let's say we have a bank. This will represent our system. And let's draw you. This is my generic picture of a student. So let's say this is you. This represents the surroundings. Let's say you have some money in the bank. When you withdraw money from the bank, what happens is the money in the bank goes down, but the money in your wallet goes up. This would be like an exothermic reaction. It gets hotter because you have more energy, but what you notice is you get less money or less energy in the actual reaction. Now, what would be an endothermic reaction? Endothermic would be like if you deposit money. If you deposit money, that is like endo. What happens is the money in your bank goes up, the money in your pocket goes down. If we look at endothermic reactions, notice the products have higher energy and the temperature goes down. Okay, so that is something that you could think of, or you can just take a look at this particular diagram to help you hopefully understand the concept. All right, ladies and gentlemen, thank you very much. Have a good day. Bye-bye.